Today what we're going to look at is part 2 of solving radical equations and focusing specifically on extraneous solutions. Now again, to quickly recap what an extraneous solution is basically just a solution that when you plug back into the original equation, it doesn't work. Okay, now the easiest way to do this is, again, guys, by graphing. These questions are also going to be asked in the form of given solutions, say A, B, C, and D. Which one of these is extraneous, or choose all of the real solutions, or identify the extraneous one. And honestly, what I would do is pull up Desmos, go y equals square root 5x, type what you have on the left side of the equal sign. And then go y equals x, type what you have on the right side. Your answer is the x value where your graphs intersect. If the x values, or if the graphs do not intersect at the given values, then it would be said to be an extraneous solution, or basically it doesn't work. Okay, what I mean by it doesn't work is that when you evaluate the function, so if I evaluate -2, I get 0. Well, if I pull up this table at -2, I get -2, so I have different y values. Okay, so it would be an extra. At -5, I get -5. At -5, I get undefined. I don't care what the numbers are. If they're not equivalent, then it's wrong. At +2, I get 3.8257. At +2, I get 2 again. They're different. So I would say B through D are extra. A is the only correct answer. Now, mathematically, if you want to do it, again, I'm not going to recommend doing it this way, just based off of the style of questions. However, you can test the work you do by actually working through it, right? Say you work through it, you mess up a step here, a step there, no harm, no foul. Your answer would just be extra, right? It's an answer that's just not right. All right. Now, so again, how do we do this? In short, what we want to do is isolate the radical, undo radical, solve for variables. So it may look kind of short and sweet, but it's, depending on the types of questions, it could be a little bit of work. Now, if I want to talk about the radical in itself, I want to get all of this in the red by itself. So the way I would do that would be add 1 to both sides. Then I would be left with square root 5x plus 11 is equal to x plus 1. So I've isolated the radical. Now I want to undo it, so I square both sides. And this is where the mistakes start happening. So I have 5x plus 11. I'm going to FOIL this. I'm not going to take the time to do it step by step. So I've now undone the radical. Now I want to solve for my variables, which is x. So again, solve for variables. Again, get x by itself. That's what we associate with solving variables. So I have 0 equals x squared minus 3x. And because I didn't take my time, I messed up. That'd be minus 10. Here, I got to get x by itself, so I have to undo factoring. X minus 5, x plus 2, quickly double check my work, is x squared plus 2x minus 5x minus 10. Combine like terms, x squared minus 3x minus 10. That's what I had here. To solve, you set your factors equal to 0, get x by itself. So I have x is equal to 5, and x equals negative 2. And again, what you would do here is you would plug these answers in back to your original equation if we were doing this by hand. So 5 times 5 plus 11 minus 1 equals 5. So square root 5 times 5 is 25. Plus 11 minus 1 equals 5. Square root 36 minus 1 equals 5. Square root 36 is 6 minus 1 equals 5. 6 minus 1 is 5, and it does equal 5. So 5 works. So you got to do all of that process to test by hand if something's extra or not. Whereas you give me A, B, C, D, I'm going to my graph, or I'm going to Desmos, and I'm testing it this way, okay? So again, just another example. I think, number 5 and number 6. So again, isolate the radical. I want to get that by itself, so I add into both sides. 6n plus 19 is equal to 2 plus n. Square both sides. I'm left with 6n plus 19 is equal to n squared plus 4n plus 4. Get n by itself. Be n squared minus 2n minus 15 is equal to 0. N minus 5, n plus 3. Set these each equal to 0. Get n by itself. And again, I can test which of these is actually extraneous by Desmos. And this is what I'm going to recommend y'all do, is just test and find. So y equals negative n. So I'm just going to use x plus square root 6x plus 19. And then y equals 2. And again, your answer is the x value where your graphs intersect. So if I look at this graph, they only touch right here. And that value is 5. So 5 is my real. Negative 3 is extra. And that's all there is to it. So again, essentially all we were doing is just solving, right? Testing solutions. I put 4 answer choices up on the board, tell me which one's right. If it doesn't cross or if the graphs don't cross at that particular x value, it can be thought of as extra.